This is exercise 5.1, Q2. I'm going to do some of the even numbered problems since the odd numbered problems are assigned for homework. With respect to these problems, we're working with 4 rules, right? And you can see there's 2 kinds of rules that we're working with so far: introduction rules and elimination rules. And you'll find that for each of the operators, there's going to be one of each. So for conjunction, we've got introduction rule, elimination rule. For disjunction, we've got introduction, elimination. The the conjunction introduction rule says if I have P on a line by itself and if I have Q on a line by itself, I could validly infer the conjunction P and Q. So I'm introducing the conjunction into this conclusion. Whereas elimination, I start with the sentence that has a conjunction and I eliminate it. And I can do that because if I know P and Q is true, I can know that P by itself is true. If you remember the truth table for conjunction, a conjunction is only true when both conjuncts are true. So that means if this sentence is true, then P must be true. Or if this sentence is true, Q must be true. Either of those are legitimate instances of conjunction elimination. Disjunction, the introduction rule says if I have a sentence P, I can introduce the disjunction P or Q. Now, you might be thinking to yourself, where does that Q come from? There's no Q up here. And the thing is, this is a disjunction. So a disjunction, if you remember the truth table, a disjunction is true as long as one disjunct is true, at least one. So if I know P is true, I know that P in a disjunction with any other sentence is also true. Because so long as P is true, the whole disjunction is going to be true. And it doesn't matter if I put P before or after, as the first disjunct or the second disjunct. That's why there's 2. Disjunction elimination now takes 2 inputs. With conjunction, we could eliminate a conjunction because we know if a conjunction is true, both conjuncts must also be true, but not so with a disjunction. So we need another input. So to do disjunction elimination, we have a disjunction and a negation of one of the disjuncts. So if I know either P or Q is true, and then I can eliminate P, that leaves me with Q. Or vice versa. If I know P or Q is true and I eliminate Q, that leaves me with P. Alright? So those are the 4 rules. I also want to show you how to set these up. I've done most of them, but when you look at the Q2 problems, they're generally like this. They have premises separated by commas, and then the conclusion separated with this 3 dot symbol. Okay? But when you do a proof yourself, you have to set it up like this down here, vertical. So what you do is you number each premise, and again, it's the commas that separate the premises. So this is the first premise up to that comma, return, that's the second premise, and then the conclusion you can put over off to the side over here, and then always put a line between the premises and then the next steps in the proof. Okay, so this is number 2, and what it says here, get rid of that extra line. So we've got, as our first premise, we've got a conjunction, right? A sentence whose main operator is a conjunction. And our second premise is a disjunction. And the conclusion we want to get to is T by itself. Now these rules are all valid inferences or valid argument forms. If you write a truth table out for this argument, you'll find it's valid. If you write a truth table for this argument, you'll find it's valid. So remember, valid arguments preserve truth. If the premises are true, the conclusion must also be true. So if these premises are true and they're given to us as true, then applying these rules is going to give us other true sentences. And they're guaranteed to be true because all the rules are valid inferences. So we basically apply valid inferences to the premises until we get to our conclusion, which is T. All right. Now, we can't really do anything with T or S. We can't eliminate that because to eliminate a disjunction, you need 2 things, 2 inputs. But we can eliminate a conjunction with just 1 input. And the dot and the ampersand are the same. Okay. So what we can do is we can get P by itself, by conjunction elimination of 1. And we can also get not S and J by itself, also by conjunction elimination of 1. Right, so we know this conjunction is true, and the conjunction elimination rule says if a conjunction is true, you can get either conjunct by itself or both. So we got this one by itself here, this one by itself here. Now this is a conjunction as well, so we can do the same thing here. We can get not S by itself, conjunction elimination of 4, and we can get J by itself, conjunction elimination of 4. Okay, so now we want to get T. Remember, I was saying that to do this disjunction elimination, we need 2 inputs. We need a disjunction and the negation of one of the disjuncts. Now we've got that. We've got a disjunction here, T or S. We've got the negation of one of the disjuncts here, not S. So as a result, we can get T by disjunction elimination 2, 5. Okay. So notice because disjunction elimination takes 2 inputs, namely a disjunction and the negation of one of the disjuncts, it gets 2 numbers after it. The first number refers to the disjunction, or one of the numbers refers to the disjunction, the other number refers to the negation of the disjunct. And that gives us T, which is our conclusion, so we're done. All right? The last line of your derivation should always be the conclusion that you're trying to derive. Now you might notice in this derivation we did a bunch of steps that we didn't end up needing to do. Like we got P by itself here, but we didn't really need to do that, right? We could have done without that. And same with, here we got J by itself, and we didn't really need that either. We didn't do anything with it. And when it comes to derivations, the general rule is try to be as short as possible. Don't do unnecessary steps if you can avoid them. But on the other hand, it's not wrong. It's not incorrect. Like we validly applied this rule to premise 1 to get P, and that's correct. Even though we didn't need P, it's still validly inferred. So the basic idea is do it as short as possible. Don't do steps if you don't need them. But it's not wrong if you do. And sometimes you don't know if you need something or not. So this is perfectly good solution to number 2. It could have been shorter, but it's not wrong. Okay, now here we've got L and M. This is number 4. We've got 2 premises. There's no operators in either of these premises. And we want to get to this conjunction of 2 disjuncts, right? Notice R and T don't appear anywhere in the premises. And that should make us think about disjunction introduction, because disjunction introduction allows us to introduce sentences that don't appear in the premise. And again, the reason for that is because if P is true, this whole disjunction is true, whether Q is true or false. So we can get L or R by disjunction introduction of 1. We can get M or T by disjunction introduction of 2. Right? So we had L, and the disjunction introduction rule says we can put L in a disjunction with anything. We had M, disjunction introduction says we can put that into disjunction with anything, and now we want to put these 2 things together into a conjunction. So that's conjunction introduction rule. If we have a sentence P and Q, we can put them into a conjunction together. So this L or R and M or T, that's conjunction introduction of 3, 4. So line 3 we got L or R, that's why the 3 there. Line 4 we've got M or T, that's why the 4 there. And this is the rule that we used. Okay. Now we go to number 6. 6, again, we have a sentence with a conditional. And then our conclusion is that same sentence in a disjunction with this big, long, complex sentence. But our disjunction introduction rule says that if we have a sentence that we know is true, we can put that into a disjunction with any other sentence. no matter if it's complex and long or short. So in other words, that's all we need to do. And we get this, we justify this by disjunction introduction of 1. See, the disjunction introduction rule takes just one input, any sentence, and it gives as output a disjunction. So again, here we had this sentence, P conditional T. We put it into a disjunction with this sentence. So disjunction introduction of 1. Okay, number 8, we've got two premises, disjunction, conjunction, and we want to get this disjunction for our conclusion. We can't do anything with this as far as eliminating the disjunction until we have the negation of one of the disjuncts, which we don't have yet. Although you can see not H is here in this conjunction. But you can't do the disjunction elimination until you have not H by itself. Okay? And we can get not H by itself by disjunction elimination of 2. Because this is conjunction elimination. This is a conjunction, and conjunction elimination says we can get either conjunct by itself. Okay, now we can get J or I because we have disjunction and the negation of one of the disjuncts. So that's disjunction elimination 1, 3. Now we need to get I or M, and we have, so we can get not J by itself here now by conjunction elimination of 2. And we can get I by itself then by disjunction elimination of 4, 5. Right, this is a disjunction. This is the negation of one of the disjuncts. That leaves us with the other disjunct, which is I. And then our last step is to put that into a disjunction with M. Right, disjunction introduction says if I have any sentence, I can put it into a disjunction with any other sentence. So I have I, so I put it I or M by disjunction introduction. Since that's my conclusion, I'm done. Okay, number 10, last. We've got conjunction, disjunction, disjunction. We need to get a conjunction for our conclusion. We can start by eliminating this. It looks like we're not going to need the not B. So there's no B's or not B's anywhere below. So we don't need, it looks like we don't need to get that, but we do need this not C and D. And not D, sorry. So conjunction elimination of 1. Now we can get rid of those. Oops. Conjunction elimination of 4. Oops. Okay, so now we've got these disjunctions. We have negations of one of the disjuncts. So we can get E by disjunction elimination of 2 and 5. Get F by disjunction elimination of 3 and 6. And then the last thing we need to do, put those together with a conjunction introduction of 7 and 8. So we had E by itself, we had F by itself, and the conjunction introduction rule says we can put those two sentences into a conjunction. Right? Okay. So that's the even numbered ones. And again, notice the numbers here, right? Numbers depends on input. So if I do the conjunction introduction rule, I need 2 inputs, 2 sentences. So whenever I have conjunction introduction, it should have 2 numbers after it. See, conjunction introduction 3, 4. Conjunction introduction 7, 8. Whereas if I do conjunction elimination, I need 1 input, right? 1 sentence. That's a conjunction. So I only need 1 number after the conjunction elimination rule, right? And you can see that here, conjunction elimination 1, conjunction elimination 4, etc. Disjunction introduction, again, I only need 1 input, any sentence. So when we have disjunction introduction, it's only going to have 1 number after it. But disjunction elimination needs 2 inputs, the disjunction and the negation.